Assalamualaikum and very good morning to everyone. My name is Nurai Kasina. Today I will present a brief overview of the main type of organic reaction. These reactions are essential in transforming carbon-based compound and form the foundation of organic synthesis or industry chemistry. Food substitution reaction involves replacing one atom or group with another. Nucleophilic substitution includes SN1 and SN2. SN1 proceed through a carbocation intermediate, while SN2 occurs in a single step with a back attack. Aromatic compounds like benzene undergo electrophilic substitution. Second, addition reaction occurs mainly in alkanes and alkanes. Two reactants combine to form one product. Common examples include electrophilic addition, nucleophilic addition, and hydrogenation, where hydrogen is added to a double bond present of a metal catalyst. Third, elimination reaction involves removing atom or group to form a double bond. E1 occurs in two steps, where E2 happens in one concentrated step and requires a strong base. Next, oxidation and reduction play a major role in converting alcohol to aldehydes, catanes or acid, and in reducing to alkanes and alkanes. Condensation reaction involves two molecules joining while eliminating a small molecule such as water as seen as purification. Lastly, reaction involves internal shift of atom within a molecule without adding or removing atom. In summary, the primary categories of organic reaction include substitution, addition, elimination, oxidation, reduction, and condensation and rearrangement. Each pathway follow the characteristic mechanism and remains essential in understanding organic chemistry. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hi, good morning to everyone. My name is Nurul Atirah binti Suhaidi. Today I am going to talk about the alkanes. First, what are alkanes? Alkanes are unsaturated hydrocarbons that contain at least one carbon-carbon double bond. Now, let's look at the IUPAC naming rules for alkanes. To name an alkane, we first find the longest carbon chain that contains the double bond. Then, we numbering the chain from the end nearest to the double bond, and we use the suffix -ene instead of A and E. For example, CH2 double bond CH2 is called ethene, CH3 single bond CH double bond CH2 is propene, and also CH3 single bond CH double bond CH single bond CH3 is both to A and E. Next, the preparation of methods. There are two common ways to prepare of alkanes. The first is dehydration of alcohol, which is when ethanol is heated with concentrated sulfuric acid. It loses water to form ethane. Next, the second method is dehydrohalogenation of haloalkanes, where an alkyl halide reacts with alcoholic potassium hydroxide to remove hydrogen halide and form an alkane. Now, let's move on to two key reactions of alkanes. First, hydrogenation, which is when an alkane reacts with hydrogen in the presence of a nickel catalyst, it forms an alkane. For example, ethane reacts with hydrogen to form ethane. Second, addition of bromine. Alkanes react with bromine water to form dibromo compounds. The orange color of bromine water disappears, which is a simple test of alkanes. Finally, let's talk about a real-life use of alkenes. Ethene can be polymerized to form polyethylene or polythene, which is widely used to make plastic bags, butters, and containers. In summary, alkenes are unsaturated hydrocarbons named with the suffix E and E. They can be prepared by dehydration or dehydrogenation, and also they undergo addition reaction, and they have many useful applications, especially in the plastic industry. Thank you.
Application. Nomenclature of alkenes. Alkenes are unsaturated hydrocarbons that contain at least one triple bond between two carbon atoms. Their general formula is CnH2n-2, and their name always ends with the suffix Y and E. When naming alkenes, we choose the longest carbon chain that includes the triple bonds, and number is so triple bond gets the lowest possible number. For example, C2H2 is called ethene, also known as acetylene. Second, C3H4 is propyl, and C4H6 can be one butene or two butene, depending on the position of the triple bonds. For the next, method of preparation. One common way to prepare alkene is called dehydrohalogenation. In this method, a dihaloalkene is heated with alcoholic potassium hydroxide, and this removes hydrogen halides to form an alkenes. For example, CH2Br minus CH2Br plus 2KOH gets CHCH plus 2KBr plus 2H2O. By this reaction, we can produce ethene or other alkenes. Next, reaction of alkenes. Let's look at two important reactions of alkenes. First, hydrogenation. Alkenes react with hydrogen gas H2 in presence of a metal catalyst like nickel or platinum to form an alkene. For example, triple bond CH plus 2H2 gets CH3 minus CH3. Second, halogenation. Alkenes also react with halogens such as bromine to form haloalkenes or haloalkenes. For example, triple bond CH plus bromine 2 get CHBr double bond CHBr. These reactions show that alkenes are very reactive because of their triple bonds. For the last one is industrial application. The most common industrial alkene is ethene or acetylene. It's widely used in oxide acetylene, welding and metal cutting. Because the flame is produced with oxygen is extremely hot, about 3000 degrees Celsius. It's also an important raw material for making plastic, vinyl chloride or PVC, and other organic chemical industry. To sum up, alkenes are hydrocarbons that contains a triple bonds. They are named with the ending Y and E, can be prepared by dehydrohalogenation, react easily with hydrogen and halogens, and very useful in industry, especially in welding.
Assalamualaikum and hi, I'm Alan Tasha Putri binti Zulkifli. Today I'm going to explain about stereochemistry. First, we got constitutional isomers. Constitutional isomers, also known as structural isomers, which are specific type of isomers that share the same molecular formula but have different bonding atomic organization and bonding pattern. Next, we have stereoisomers. Stereoisomers is isomers that are different in spatial arrangement of atom rather than order of atomic connectivity. One of their most interesting type of isomers is the mirror image stereoisomers, which are non-impossible set of two molecules that are mirror image of one another. The existence of these molecules are determined by concept known as chirality. So, chirality means a property of a molecule whose enantiomers are superimposable on their mirror image. The term chiral refers to anything that cannot be superimposed on its own mirror image. For example, our hand. We cannot superimpose our left hand on our right hand. Also, we cannot fit our left hand into right-handed glove. This is because our hands do not have a mirror plane of symmetry. For enantiomers is a non-superimposable mirror image. They interact differently with chiral environment, taste, smell receptor, or enzyme. For example, smell is detected by receptor in the nose, and the molecule must fit in the receptor site. So different enantiomers will only fit with a specific receptor site. Next is optical activity. Optical activity is an effect on optical isomers interaction with plane polarized light. For example, sugar. These biomolecules are chiral and strongly rotate polarized light, which are important in food science and chemical synthesis. Diastereomers are stereoisomers that are not mirror image of each other. They have different physical and chemical properties and might have a multiple chiral center. For example, glucose has many diastereomers. For mesocompound has two or more chiral center, but has an internal plane of symmetry. For example, mesotartaric acid. For the last part is a racemic mixture. A racemic mixture contains 50% of each enantiomers. For example, some drugs are sold as racemic mixture before being purified into a single active enantiomers. So that's all from our group. Thank you.